Guys, hello, sorry, hello, mentioned. How are you guys doing today? This workshop is going to be a little bit there. Oh, chat. Yes, we're small class teaching. Exactly, exactly. This is going to be a little bit different. We're going to be doing an inventory, but the script is basically non-existent. So it's going to be, it's going to seem maybe a lot less organized. Uh, in any case, off we go. So where did we leave off last time? We had movement, we had enemies. We've got these items currently. Oh, pardon me. Yawn a little bit. We've got these items that when we run into them, we increment some score. Yeah. That's a little bit boring. Maybe we want to have something else. Maybe we want to have an inventory, right? If you think the item is quite generic right now, it's literally a yellow cube. Perhaps you could have a green cubes for some kind of boosters, right? Maybe a little health potion. Maybe you can have small red cubes for weapons to increase your damage if we implement damage. So you could have it so that as soon as you touch it, it just applies its effect and you don't ever really keep track. But say you wanted to keep track, say you wanted to hold on to like the potions and you didn't want to just have it for fixed potions, maybe you wanted to have a different wide range of potions and you didn't want to have individual counters and lists for each. Right now I might not be making too much sense. Hopefully it'll make slightly more sense as we move forward. So we want to get an inventory working. What do we need? Oh, do I go into paint and try to paint? No, we're not going to do that because that's just going to turn out awful. First things first, actually, we need to fix a small defect in the collector, script. So going into collector, you've got this stateful item route. No paint, no paint. Oh my goodness, let's see. What I meant was, say you've got potion 1. Oh, this is an arrow, yeah. You've got a. Oh, come on, I can do this. What other things? So let's call this H and let's call this M, right? We want to have all of these different items. What kind of stuff do they all share? The answer is not a lot, by the way, other than these two. One way we could group these, I guess, is into consumables. I don't have a drawing pad, so it's kind of iffy. Yeah, let's draw this. This is totally armor. Meant. Mouse cursive, we love it. Right. What do these two groups share? Any idea? You can use them. Yes, sure. Anything else that they share? Anything else? You can hold them. Sure, maybe. They can go into your inventory. Yes. So you can use all of them. Yeah, honestly, me neither. I'm going to suggest that we also give each of them a name. Right. So health potion, mana potion, arrow. So that way, Rosemary. My sword named Rosemary. Sword, whatever, armor. And why I wanted to ask this is that we can these can now be fields in an interface item. Yeah, interfaces. We love interfaces. And like actually a bit more concretely, we'll then be able to using this interface. We'll then be able to build an item base. Oh, god damn it. And then from there we can have like specific because the use is going to be different for each of these. Like when you use a health potion, you want to get back health. When you use a mana potion, you want to get back mana. When you use a weapon, you want to attack. And there's really no good way of implementing that generically. Like we could have individual classes for each of our mana potion, health potion, sword. That gets a bit funky though. We'll see. For now, we've got a starting point of these two things that are shared between all of these. Okay. One extra thing I'm actually going to add is like a maxed stack size, and then it is stackable. So, oh no. See, I haven't actually used this in approximately forever. So. Okay. You know what? Leaving. Leave paint. Paint was a mistake. Let's actually just go back to Unity. So let's create our thing. Create C# script, and let's call this item base. Yeah. Double click, open it up. Now item base is going to be a bit special because first of all, it's going to be abstract. So we can't actually have instances of item base. You have to override, you have to implement it or rather inherit it. And we're actually not going to have a mono behavior here. We're going to have a scriptable object. Scriptable objects are sort of different from mono behaviors. The main difference is that it makes this class and its child classes singletons. I'll explain it. I'll show you a little bit more what that means in a sec. But let us add the previously mentioned. You know what? Let's add the interface here. Public interface item. And what did we say? We wanted a string name read only, and we wanted a void use. Cool. And I did mention also the bool is stackable gets and let's say int max stack size. Yeah. This will help us more when we get onto the inventory. Because, for example, a sword, like if you play Minecraft, which you should have at some point, swords aren't stackable, dirt blocks are. Similarly, maybe you want potions to be stackable, so you can hold a stack of like 5. But maybe you don't want armor to necessarily be stackable. Maybe you want armor to take up its own slot in the inventory. That's the main use case for these, right? Well, you know, it depends on the game. For example, in Minecraft, they're not stackable, but in Terraria, which is better Minecraft, sorry, something in my throat, they stacked like 20 or 75 or 99. Yeah, it's great. Anyway, moving swiftly on. Let's implement the interface for our given class. Luckily, you know, Visual Studio, nice little hotkeys, helps us a whole bunch. Okay, it's implemented ideally. Let's not do that. For now, yeah, return false. And finally, get return string. Okay. And this is actually going to be abstract because we want each implementer of item base to have their own definition. there isn't actually a shared definition for use. I mean, it might seem similar for mana potion, health potion, but then you can create a actual dedicated base class for those. Because there's not much that's shared between using a sword and using a potion, for example. That's kind of what I'm getting at. So we'll leave it as abstract. We'll let the implementer decide. So currently we have properties, and if we return to the Unity Tools project, if we return to the Unity editor, this doesn't actually help us very much because it's a scriptable object. We can't, for example, add it as a component. You see, if we try to add it to spawner, we can't. Also, it's also abstract, so big L's. So to build off of this, we're now actually going to create two more. This will be collectible item, and let's do equipable item. Why not for the sword? Create a shop, equipable item. Yeah. Let's open those two up. Oh, our script is getting rather large. It's fine. What do you mean? And this will inherit from item base. No. The more code, the worse the game. Come on, simplicity. No bloat. Oh my god. Okay, let's give this a little message. I don't know about that. 100k lines of code. I mean, depends on the game. Okay, depends on the game. Name. Quit. Name. Sure. And that'll be our equipable item. And then where's our consumable item? Not there. That's brilliant. Oh, I named it collectible item. Oh, damn. I don't know what I'm on about. That's fine though. What do we want here? Consumable item. There we go. Now we can open this and implement this. It's gonna be great. And of course, inherit from item base. Oh Lord, hotkeys. No. No, you know what? Public overrides void use. We're gonna get rid of this not implemented exception. .log, and what do we want to log? Consumed name. I keep using the JavaScript interpolated strings, and I still have PTSD. Okay. Now that we've made the scriptable objects, if we try to add it to here, come on. Yeah, we can't actually add it because it's not a mono behavior. That's all I wanted to show. Okay, so now that we've got that working, the hell, okay. Let's open it back up. Let's open up consumable item and item base. So these inherit from scriptable object, right? What's so special about them? Scriptable object is a singleton. So when your game starts, one instance of it will be created according to the data that you set. And we're actually, you know what? There's an attribute that you can use. Pardon me. There's an attribute that you can use to create a nice little menu for creating these things. So create asset menu. What will be the file name? Mentions the default file name. So the default file name, let's use this, equals new consumable. The menu name equals yeah, let's do items consumable. And likewise for equipable, we'll copy, we will paste equipable items. Okay. If we go back to Unity, Yeah, let's right click, create. Oh, and you see items at the top, and we can create a new consumable. Let's actually create a folder called items first, just to hold all of it. So we have some semblance of organization. So create items, consumable. Let's call it test consumable. And let's create a new items equipable, test equipable. And here is our scriptable object. You see it doesn't have anything because we used properties. So let's actually go back to item base and let us give it some parameters, quote unquote parameters. Serialized field, private string name, serialized field, private bool is stackable, serialized field, private int max stack size, and that's it. Those are the things we need. And then here we need to, of course, return the relevant fields. So we don't return like default values anymore. Stack size. Cool. If we then return, we should, yes. So equitable. It's not stackable, max stack size of 1. And a consumable, what should we call this? Test consumable. Let's be very ambitious. Consumable. No, not going to be food. You know what? Let's create a few more then. Consumable, food. Let's create a potion. And food. Let's leave it as not stackable. Why not? Can't really stack a Sunday roast, can you? Okay, so we've got our items. This isn't Minecraft. And steak, I guess you could, but no. No. Okay, what we're going to do now, we've got the item base. Right, I don't remember. I know what we're going to be doing today. We've got consumable, we've got equipable. We now need to actually, okay. Let's go to prefabs, or rather in here. Now let's drag in the item. No, why not? No, you don't need to even drag it in. Yeah, we need a new script. So we've got, oh, pardon me. We've got the different items, but you saw that we can add them to anything. Well, we can't actually add it to the prefab. Nothing happens here. So we need to have some way of holding a reference to them. So we're going to go into scripts. We're going to create a new script. Let's create it in items. Let's create it in items. And will this be pickup? Sure, let's call it pickup. Why not? Come on. Cool. Serialize, add a new private variable to store a reference to the item base singleton, basically. So item, and let's also give a public thing. So item. Get return item. Oh well, you see, I was very boring. And this stuff happens. Oh no, Rip Ninja. He just couldn't. He could not handle this. Oh. I mean, to be fair, I'm waffling a lot, and there's not really a good structure here, so I can understand why he left. Pick up. We've got this. Cool. Now's the time we're going to collect.cs. So this is what does the score. This picks up a little yellow cubes, and it does a score. Right now, it doesn't do anything else, which is a bit disappointing. In fact, I don't even know why we have the stateful item root. To be fair, you know what? Scrap it. Scrap this stuff. Just get rid of it. It's fine. Get rid of it all. Yeah. Okay. So go to player controller.cs. Because we need to. We currently have a singleton, and of course, if we don't destroy and load, so we save the object and ensure that there's only ever one instance of it in the in our game, but we can't actually access this instance from outside. Pardon me. We can't actually access this. We'd have to use find all object of type or something else, some other slow method to get a reference to the player. Because we already have a static instance, what we can do instead is have a public static property, player controller instance get return instance. Oh Lord, cool. That should be good enough. And then we're actually going to make. Oh no, I've just realized I have to make a bunch more stuff. Oh, he's back. Yes, hello, Minjin. You're back. We actually have to make a bunch of other infrastructure stuff. Yeah, there's see, this is the issue when stuff isn't planned ahead of time, or at least isn't planned very well. So we have an instance, but we can't actually do anything with it right now. Okay, I know what we're gonna do. Add a public stats property. So yeah, stats. A get and return player stats. And similarly, no, for now, that's all we'll do. For now, that's all we'll do. And go into player display.cs and here, because I've been meaning to do this for a bit. Because for later on to make it nicer to work with, later on, we have to basically clean up a bunch of old code. Here you saw that was setup references, teardown references, and they were taking a single parameter. Now, back when we added these methods, that was fine because we only had player stats to worry about. But now, because we'd like to start displaying player UI later, maybe we won't get to this in this workshop, right? But maybe you'd like to, on your own, extend the UI to show your inventory, right? It'll make it slightly cleaner to work with. So plus, because we weren't really using the singleton here, which we might want to do. So basically get rid of the setup references and teardown references methods. So before we had setup references and teardown references, cool. Basically copy this bit, get rid of them, and create a new public void setup method, which will do this. Now, we don't have passed the parameter anymore. How are we going to get a reference to the player stats? Player controller dot instance dot stats. There we go. And now we have a reference to the player stats. Because there's only ever going to be one player instance, this is fine. In fact, we can do current stats here. We need to start using it everywhere, right? This is now also fine. Cool. This is very good. We've fixed player display. We'll come back to this later. We've sort of done player controller. Oh, I'm missing a curly bracket there. Okay. Okay, yeah, and now we need to get rid of the onEnable onDisable methods and replace it with a private void start, and we'll do HUD dot setup. Awesome. So replace the onEnable onDisable with just a single start method player.setup. Because this will be a singleton, because the HUD's currently on the player object and that's ported between scenes, this will only ever have to run once. Okay, and that's actually mostly done. Mostly, we'll get back to this. Go back to the Unity editor. Oh, yes. I forgot. We need to actually completely clear that out. I'll mark it with a little to-do. So clear out your collector. I forgot to do, my bad. And go back to the Unity tutorials project. Come on, reload. Awesome. Now if we play, we shouldn't be able to actually interact with the things. Yeah, like we can't actually collect them anymore. Cool. So go into items, right click, create, C# script, and inventory. Okay, we're moving on to actual inventory stuff. Only 30 minutes in. Okay, open up inventory in whatever editor you want. And you know what? It's not going to be a mono behavior. It's not going to be a mono behavior. This bit's going to get a little messy, but that's fine. So add a constructor. We're going to have a max slots field. So it'll be, you'll only be able to have a fixed number of slots. If you want after, you can extend it to infinite. It should be relatively easy. So that's just a Boolean, and then a few checks that we'll do later. You just need to show Boolean. Okay. What do we need in the inventory? How are we going to store it? Oh, can I is there a way to clear this completely? I'm not even sure there is. New. Don't save. Oh, paint is wonderful. What do you mean? So one way we could do it is to have a fixed number of slots, right? A la Minecraft, 9 slots on your hotbar, and have many, I think 36 slots in your actual inventory, right? And then we just have to iterate. So say we've got a health potion here, a mana potion here, free space here. When we want to add an element, you have to just go along and find the first free one and then insert it there. So we'll insert a sword there. Cool. Then when we're looking up this, when we want to remove something, of course we'll have to go along, find it, and then just remove it. Cool. What happens if you do add a sword, you then add maybe an arrow, and then you remove a sword, right? So then this happens. It's going to be great fun. You then have to actually iterate through and either keep track of, so you either have to iterate through every single time when you want to add something and find the first free slot to put stuff in, or you actually keep track of empty spaces in a separate data structure or wasting some memory. Yeah, basically, this is what happens if you use an array list for your slots. You can run into issues where you've got little gaps. What we're going to do instead is use a dictionary, because if you use a dictionary, you don't have any of these issues, right? Because a dictionary, it uses a list, but it uses it internally, and it's all hidden for you. It's really nice. All we're going to have to do is we're basically going to map an item, a base. I really wish I had a drawing pad, but alas, I don't. To a list of slots. Right. So each item base, so for example, health potion, mana potion, arrows, will map to a list of slots, and we'll keep track of the count separately, right? So we'll enforce a maximum size, but we won't actually have to use an underlying array for it. This brings its own issues. Pardon me. For example, it becomes much more difficult to display your slots if you don't have an array, because with an array, you can just return that, right? You can read from the array and you can construct a grid really easily. With this, it becomes much harder. You have to basically returning the list of slots is much harder, but we'll get to that. We'll get to all of that. For now, let's just do the starter code to get to basically let's add all the fields that we need to have an actual inventory the way we want it. So private read-only dictionary. We want item base, so we want references to the singletons that we create, and we want to map this to a list of slot. Slot isn't actually created yet, so bear with me. Inventory slots. On top of this private read-only int max slot count and let's have a slot count. So these are three things that we're going to need for a basic inventory. And of course, I mean, let's just create them as well. Debug.assert max slots greater than 0, and the message shall be try to create negative just some nice debug stuff. Why not? So max slot count equals will this be max slots inventory slots equals new dictionary, and what we want int capacity, awesome, max slots, and of course slots counts equals 0. That's default, but it's fine, we can add it. So you notice that we've got this this slot type that we haven't implemented yet. The way we're going to implement it is with an inner class. The way you declare that is just public class slot within inventory class. We could implement it outside. No, so debug.assert will basically throw an exception when this condition is false, I think. Let's double check that. Oh, damn it, I said let's check that. Condition you expect to be true. Yeah, so if this condition is ever false, so when max slots is less than or equal to 0, it'll throw an error and it'll show this message. That's important because here we pass it in as an int, and because we can never really trust ourselves or the user, we have to basically just check. It's going to be nice because when the error occurs, it's going to show us a nice assert message, maybe with even a stack trace if we're lucky. So the slot. For now, let's leave it. And we'll just pretend it's there. We'll actually declare the methods that we want our inventory to add. So, what methods do we want it to have? If you think about it, in an inventory, you want to do one of like 3 things. You want to add to the inventory, so you want to add items. You want to be able to look at what items you have, and you want to be able to remove items. Right? Can you think of any more? Oh Jesus, my back. So I think that'll be enough for now. Oh, no worries. Okay, so let's add and because each of these methods could fail. Like for example, when you want to add to an inventory, what happens if the inventory is already full? Well, you're kind of screwed because we've used an inventory with a fixed capacity. The item just can't go in. So we're going to actually basically tell the programmer that up front by making this a try add method. So we need to add an item. And for now, it will just be a stub method. Will return false. We want to also try peek item base item out list. I read only list slots. Return false slots equals null. That's our stub method. The reason like peek could fail is, well, what if the item hasn't actually been added? We could make it so that it never fails and it just returns an empty list, but then that requires us to store that empty list somewhere. And it's not really necessary, right? We can just fail saying false the out parameter isn't actually initialized, can't use it. By the way, this kind of try method with an out parameter, it's quite common in C#. It's really useful. It allows you to write stuff such as if try peek item out var here, and I read only list slots, and then inside this you can then work on slots, so slot.count plus equals 1 or whatever, right? Because you know that if this returns true, then this should have been initialized, and if it doesn't, you don't touch it. It's a really nice pattern. We'll use it a little bit later. Anyway, we've got adding, we've got reading. What if we want to remove an item, right? So public bool try remove item base item. So just remember, item base here is like our key. It's our key in the inventory because we map item base to a list of slots, and we keep track of slot count ourselves. That's why we keep passing it here. Now, what's because we store a list of slots, we can't just, and because we want maybe once you have a max, and because we have max stack size, because maybe, pardon me, maybe because when you've got max stack size, maybe once you've got over 20 potions or whatever, you want to start another stack when you receive another one. Because we have multiple stacks, basically, we need to pass in an int slot index, so we know from which stack to remove. Anyway, that's in the stub method. Okay, so we have our inventory. We have our 3 basic methods. What could be nice is to actually take a nice little look, so to be able to read the inventory slots a little bit easier, right? Instead of having to call try peak item, maybe we want to read all the items in our inventory. The way we're going to do that is through the use of properties, because it doesn't really make sense to use a method. I mean, a property is just nicer to work with. A property is a method, but that allows you to work with it as a variable. So let's add that. IEnumerable, and what we have item base items get return inventory slots.keys. And let's also have an IEnumerable slots get and return inventory slots dot values dot select. Yeah. So go to the top of here and add another using system dot link and slots. So IEnumerable list slot. Oh, because we want to oh Lord. Slot dot let's actually see the function word type, because I might have forgotten that. Oh, I want to select many slots. There we go. Now, I've just written this really long and incomprehensible line. What does it actually mean? So, IEnumerable is an interface to any kind of collection. It allows you to use for each over it. So, for example, I could do for each slot in slots, and I can only do that because it's an IEnumerable, right? It represents just a collection of some sort, a read-only collection. I get the values. So in this case, this is a list, well, essentially a list of all list slots in the dictionary, right? And then I use this extension method, this really weird method called select many. So select many is part of link. Link is C# specific. It you can think of it as a BTEC SQL, but inside the language. There's two kind of ways to use it. One is through the extension methods API, and another is some really weird API. So slots equals select. I'm not even sure what the other way of writing link is. I always use extension methods. That's what we're using here. Select many basically allows you to turn a list of lists into a flat list. It's really useful like that. And because we want to turn this list of lists into just a single list, we use it and we just return the values. So what this does is it changes an IEnumerable list slot into an IEnumerable slot. That might not have made too much sense. Which parts didn't? None. Okay, cool. Moving on. If you've spaced out again, this is your fault now. Feel free to just interrupt me at any time and ask. More than happy to. Okay, none of it made sense. Cool. How do I explain this then? So we've got a dictionary, right? And the dictionary stores keys and it stores values for the keys. It stores key value pairs. Inside, it has to hold all of the keys and it has to hold all of the values. And you can think of the dictionary as just storing two lists. Yeah. You know what, sort of, maybe. MongoDB, I haven't ever used it. Is it a key value pair? I'm not sure. But it just stores keys, it stores values for those keys. We can access the keys and we can access the values through the relevant properties. So when we return items, we can just return .keys. And when we have values, unfortunately, we can't do the same. So because we want to have a list, we want to effectively return a list of slots. Think of this as a list of slots and as this is a list of item bases. Yeah. Because this is already a list, we can just return it. And because this isn't a list of like slots, it's a list of lists of slots, we can't just return it. We have to use this select many to convert a list of lists into a single list. So this kind of unwraps the list, if you will, right? It flattens it out. It converts from a two-dimensional to single-dimensional list. That's what it does. Hopefully that made slightly more sense. Anyway, we've got our items, we've got our slots. Okay, so this is the base inventory done. Now we need to actually work on this little slot because currently it's completely empty. What does it actually do? So when we have a slot, yeah, let's make it public. So slot, and we'll take an item base. This has to be generic across different items. Because the inventory will be able to store anything, we're going to want this to be as generic as possible. We can't use generics here. We can't actually use a generic thing because we don't know the type at compile time. We'll only know it at runtime. So we have to use a base class here. So this means we'll have to store a reference somewhere, item base item, and a private int current stack size. Cool. So this dot item equals item, current stack size equals 1. Okay, so we've got our private fields, we've got our constructor. Next, let's have a few properties. When we're interacting with a slot, it would be really annoying to have to like get the item and do item dot max stack size or whatever, because we want to know the max stack size so we can basically add into a slot until it's reached its maximum capacity, and once it has, create a new slot. So we're going to have public int current stack size to get the current stack size. So because we need that. Get rid of return current stack size, and also we'll have the public int max stack size. Get return item dot max stack size, Okay. We could have an is empty is full method or property as well, but you know we're going to do this. Additionally, we need two methods because you've got an item stack. What do you do to an item stack? You can only really add items to it and remove items from it, right? So what we're going to do is we're going to have another bool try add. So try push because you're pushing to a stack, and we'll have count and public bool try pop int count, and we basically want to. We might want to return whether the stack is currently empty without having to access the current stack size again. So we'll actually, as a convenience, we're going to add an is empty out parameter here. And you know what? It's just a naming convention. So the whole try thing is a naming convention. I could have just pop here. I'll return false. I'll give them stub implementations. And just right, because that is empty equals false. So I can still do a pop count out bool is empty. The thing that allows this is the out parameter, right? Out parameter specify. I think that's what it's called. It's this keyword. It doesn't. It's a naming convention because I mean, when you read this, how do you read this? If pop count out bool doesn't really make too much sense. If try pop, then you know that it gives you more in context as to when this will be valid and when you can use it. Plus, it's just a neat naming convention. It reads better, basically. But you can still use this like debug.log. You can still use it just fine without the naming convention. Okay, so those are our two methods. Yeah. No, let's actually implement these. Yeah, I mean, it's the main idea is self-documenting code, really. Okay, let's implement these two things. Yeah, that sounds like a good idea. So try push. We've got pardon me. Pardon me. Okay, so we've got max stack size. If count is less than 0, return false. We cannot push negative numbers of items. Otherwise, if count is, well, let's say if current stack size is equals max stack size. Let's do plus count. No, yeah, greater than or equals max size. So greater than or equals to max stack size. Well, no. We just want this to be greater than. So if the current stack size plus the count is greater than max stack size, return false. Otherwise, we can do current stack size plus equals count and return true. There we go. Very simple. Right. So when we try to push 1, if the current stack size plus 1 greater than max stack size, return false. Also, we can, because maybe the item isn't stackable. Yeah. Because I remember adding. Yeah, we've got it is stackable. So what happens if we want to stack a sword? Well, it's got to fail. You can't stack a sword. So what we're going to need to do is add a if not is item dot is stackable. Or yeah, because it'll always have stack size 1, and then we can't add anything else to non-stackable items. There we go. Moving on to pop. Pop also quite easy. So if count is less than 0, return false. That's quite self-explanatory. We don't care about whether it's stackable or not, because we'll only ever have one stack, either one or more elements in it. So it's fine. Plus, if you remove, you can remove an element from a stack. It's not an issue, even if it's not stackable. So if count is greater than current stack size, return false. That'll be a stack underflow. Okay. And what do we want to do? We want to do current stack size minus equals count. And then finally, if is empty equals current stack size equals 0, and return true. Yeah, cool. Yeah, there we go. We can actually initialize this even earlier. We can just move that initialization up here, because we have to initialize out parameters before we return. But we know here that, if the current stack size is equal to the count that we're popping, it'll end up being empty. In any other case, one won't be empty, so it's fine. And plus, if this returns false, if a try method returns false, then the user shouldn't ever rely on this value being correct. So by convention, it should be safe. Cool. That's the stack actually done, the slot rather. And you can make this read-only if you want, because we don't actually ever change it. We construct it, but then we don't change it. Okay, so we have slots. Let's implement the add, peek, and remove methods. So read-only is like final. Yes, exactly. Just like final stops you from being able to set a value after the constructor ends. The exact same with read-only. You can only set it in the constructor, and you can't afterwards. Okay, so public bool try add. If item equals null, we fail. We can't add a null item. And now here comes the fun part. So dictionaries have this cool method, inventory slots dot try get value. This is a try method at work. It's wonderful. List slot. Let's just call it slots. And because we want to keep nesting down, so nesting is in the number of braces that we have. So we don't want to have long chains of if, because that just means you've got less space to work with. It looks ugly, right? Let's see. So what's the shortest thing that we can do? Sure. If we haven't added the item before, so we don't actually have any slots for it, we're going to do slot new slot. Okay. Before this, let's have a slot new slot equals null, and then a new slot equals new slot item, and let's have inventory slots. No. Let's have we need to then create a new list slot, slot list, new slot list, list slot, and we'll just have the new slot in there. And we'll have inventory slots dot add. Item and new slot list. And we'll have to have our slot count. We'll have to increment that because we're adding a new slot. Oh, I remember we missed out an if check. Which if check did we miss? Bearing in mind that our inventory is finite in size and we're going to be adding slots to it. Yes, we missed out the check to see if it's full. I'm silly. So if stack size, slot count equals max slot count, we need to return false. We can't add any more slots because there's just no space. And after this, we can actually return true because we've successfully added the slot. We know at this point that the slot count has got to be any value other than max count, and because we add once, because we add one at a time, this is not thread safe. But if we add one at a time, we know we're less than essentially. Yeah, that'll be fine. Okay, so we've handled getting a value. What about when we've handled adding a value when it doesn't already exist? What happens when slots exists? What happens if we've already had slots in there? So if not item dot is stackable, oh Lord, what's our logic here? What's our logic here? No. So if item dot is stackable, so if we can stack stuff, we need to get latest unfilled stack. We need to then add to the stack, and yeah, you know what? We'll leave it at that. It's quite simple. So our slot unfilled slot equals slots slots dot count -1. So that fetches the last slot in our list, which should always be unfilled. Yeah, this is a bit scuffed. No, we're not going to do it this way. Yeah, I was thinking, but then I just realized, no, it won't be. I'm chatting out my ass. Actually, if you remove from any slot index, you have no guarantee of that. So no, you're completely right. Thank you for catching that. So what we're actually going to do, slot unfilled, slot equals slot dot. Can I do first with yes, I have a predicate. That's great. Awesome. And at this point, we know that because if value doesn't exist, all right, if slots doesn't exist, we add a list with at least one slot. So we know that first will always return the value. It'll never throw an exception. We don't have to use first or default. It's great. So first and slot dot current stack size less than slot dot max stack size. And then we'll have to if unfilled slot dot well, no, we know that that's the first slot of its kind, so then we can unfilled slot dot try push. Let's only add one because we're simply adding a single item. We don't have count here. We'll just add one for now. And you know what, we can return that. Alternatively, if it's not stackable, ooh, what happens if this predicate fails? What happens then? Fault. I need to check if it's null or not. So if unfilled slot not equals null, yeah. You see, I'm having to think through this a little bit. This is issues. Yeah. This if I hadn't changed that, if it was still first and no slots, every single slot was full, when it would throw an exception. And we don't want to throw exceptions. We're in a try method. We're returning a bool. So we have to actually check to see if the return slot isn't null. Okay, this is fine. And finally, we have the case where either the item isn't stackable, so you can't have a stack of more than one, or the all slots were filled. So in this case, we still have to do we just have to do equals new slot item. We then have slots dot add new slot and slots count plus plus. Awesome. There we go. We've got our method. It should more or less work. Fingers crossed. Fingers crossed. Okay, implementing try peek. This one should be really easy. It's as simple as if item equals null, return false, and then return, well, all success equals inventory slots dot try get value item out list slots slot item slots. Let's just call it temp. And then slots equals temp and return success. So the reason we do this and we don't just pass through slots, which you can do, you can pass through out values. The reason we can't do this is because the out parameter is a type iRead-only list, and this returns a thing. This returns a list. So we actually have to, store it in a temporary value. That's fine though. That's our method done. And here we can't really put this anywhere else. We can't move this up here because we don't know until we make this call. And we can't make this call until we know the item is null. Okay, finally, removal. Oh Lord, removal. So if item equals null, return false, can't remove a null item. Then we need to get a list of slots. So if not inventory slots dot try get value item out list slots. So if the item doesn't actually exist in the inventory, return. We'll return true. We'll silently ignore the failure because there's no reason not to. We just won't have to decrement anything. So it's a silence. It's ignoring the error essentially. Finally, so we know here that slots exists because this returned true, so this branch didn't fail, or rather it did fail, it didn't get computed. Okay, we've got slots, so slots. Now we need to check if slot index is if it's less than 0 or what's the word for it? Slots dot count is less than slot index. Or in fact, this can be less than or equals the slot index. Here we need to also return false because our index is out of bounds. Otherwise, our index is inbound and we have slots. So slot equals slot index, and then we just do bool success equals slot dot try pop 1 again because we're just removing a single item. Out bool is empty. If we're empty, what happens if we're empty, right? Oh Lord, we want to do slots dot remove at slot index, and then we just return success here. Well, you see, here's an issue. Here's an issue. We're relying on the value of the out parameter, not actually checking if this is successful or not. Let's change this a little bit. I just caught that if slot.try_pop one out ball it's empty. Slots.remove at and slot index. Yeah, because we can only do this when it returns is empty. And here we can just return true, because try_pop is this will always return true basically, because we're only ever returning one at a time. As an extension, you can try to get, because we've let try_pop take an arbitrary count, you can actually add a count parameter to these yourself and see if you can get it to add and remove arbitrary numbers of items. That could be quite a cool extension. So at this moment, we more or less have our methods done. You know, 3 methods to access the inventory done. Now, finally, so we can add stuff. We can look at the stuff we can add stuff to our inventory. We can look at the stuff in our inventory, and we can also remove stuff from our inventory. We don't have a good way of checking when something's changed. We don't actually have a good way of knowing has our inventory been updated. Can you think of a good way to do that? How have we done it before? Inventory UI. Not necessarily UI, but to help build the UI, right? Because currently, to see if something's changed, we'd have to poll it. We'd have to consistently, every frame, read the inventory and see if there's been any changes from last frame. Is there a way we can not do that? Is there a nicer way? Okay, invoke. Okay, what's invoke from? Yes, event handling, exactly, events. We might want to have an event here. So for example, an event, public event action, and yeah, let's call it slot. Slot changed. I can't spell, it's great. Using system. So we have to go up to the top and add a using system directive. But after that, we can just use the action. And we want to have the slot changed action. So now we'll be able to know which, so maybe we want an index as well, you know? Maybe we want to actually have an index. Okay, what I'm actually going to do here is add a few parameters. And int. I'm not sure what you're typing either. So this just declares an action that takes parameters item based. So this will be the item whose slot has changed, a reference to the actual slot. So maybe we don't want the slot there. Maybe we don't want the slot. Maybe we'll just have the item and the slot index that changed. Okay. And then we have to invoke that, right? Where are we going to need to invoke it? When does the slot change? In which methods? From try add, try peek, try remove. And specifically where in those methods? Yeah. I think that we're going to need to do it anytime we increment or decrement slot count, right? That's not, whenever we do that, we know that a slot has changed somewhere, so we should do it there. Yeah, that sounds right. So let's do slot changed dot invoke item, and in this case it's 0 because we know that it's the first slot to be added. Here, well, we know here it's going to have to thingy. Can I get the index? Oh well, I can always do slot changed dot invoke item and slots dot count -1 because it just adds it to the end. Otherwise, here, this is an issue. Yeah. Is there an extension method? Slot unfilled slot null int slot index equals slot dot index of. Do you have predicate? No. Find index. Oh, we actually do. Oh, that's brilliant. But what the hell is a predicate? This is a good question. Slot slot dot current stack size slot dot max stack size. Let's do a slot index not equals -1. Oh, not equals a -1. Equals slots slot index. Yep. And all 6 if try push slot changed dot invoke item and slot index. Okay. Return true. Yeah, because this ensures that our stack size is that there's still space in our this finds the first unfilled stack or -1. Yeah, so we know that this will always succeed. Okay, in that case, because we know it will always succeed, what we can do dot try push 1, and then we can just do a slot changed dot invoke item slot index. Awesome. And let's just ignore the return value. There's no need for it. If you extended these to actually use arbitrary counts of items, to add arbitrary counts, you're going to need to handle that, because then you might not actually return true with this, but we do because of this. Okay. I'm going to need to look up the documentation to find index because I'm not sure if it actually returns -1. C# find index list. Find index. Does it return? Oh Lord, does it not actually? Okay, it does. It does actually return -1. Okay, that's brilliant. That's brilliant. Going back to Visual Studio. Okay, I think we've actually finished our inventory, more or less. Okay, that's good. So open up player controller.cs. We're gonna actually try to get it slightly working. We're running out of time. Oh Jesus, we've got 10 minutes. Okay, let's try to really quickly get it working. We're not going to be able to touch UI, unfortunately. I'm sorry about that. But we'll find it so you can use keys to access it. I guess you can do. We'll link some resources at the end. We'll make sure to link some resources so that you can do the UI on your own. There's loads of good tutorials out there. Oh Lord. Private inventory. Player inventory. public inventory get return player inventory. Yeah, serialize field private int inventory capacity. Let's call it inventory size, so you can edit it, and then in await, if player inventory equals null, player inventory equals new inventory, and it'll be inventory size. Awesome, awesome. That's really nice. So what do we want to do? Okay, let's not let's remove the inventory thing. No, okay. Oh Lord. No, leave it. It'll be fine. It'll be fine. Okay, so player controller for now is done. Go into collector.cs, and you see that we have this handy to do. Let's get rid of that. What we're going to do now is check for pickup equals other dot get component pickup. So we need to first check if the other component even has a pickup option, pickup component not equals null. So if it does have one, what we're going to do is inventory player inventory equals player controller dot instance dot inventory, and then we can go player inventory dot try add item base. Yeah. Pickup dot item. Let's see. Debug dot log. Okay, no. Bool success equals debug dot log. It'll be success. This should always succeed. If not, well, issues. And then if oh, you know what? There's a nicer way to do this. We made them try methods. We might as well use the try method aspect. Destroy. And we're going to destroy the pickup and dot game object. Awesome. That should be that done, right? Well, there's only one way to check, really. Okay. Okay, enter the Unity editor. Go back to your scene. Oh Lord. Go into assets, prefabs, item. Go to assets, scripts, items. Select your item prefab. Drag the pickup script onto the thing. You'll see that now we've got a new item base field. Let's put some test consumable on that. Awesome. Now, if we start running over them, fingers crossed, fingers crossed. No, okay, it failed. Why did it fail? I'm disappointed in myself. Asserts. We. What have I forgotten to do? What have I forgotten to do on our player? Why has the tried to create an inventory with negative capacity a message shown up? Yes, inventory size, it's 0. Oh, let's call it 10. Let's call it 10. We have 10 slots in our inventory. Oh my goodness. Of course it's not going to find it. Oh, they're disappearing. They are disappearing. That's amazing. Currently, of course, we don't have a UI, so we don't know if it's where it's going. So let's fix that right now. Okay, go to open up playercontroller.cs. And this is just going to be really bad test code, but private void update. If input.get key down keycode.e, good old Minecraft. If input.get key down keycodes.q. Inventory success equals inventory dot try peak item. Yes. So IEnumerable item base items equals inventory dot items. Cool. If items dot count. Come on. I need to add this. Just using some generic. We're running out of time. Dot first. Oh, I don't have a link. That's why. Using system.link. Okay. If items dot first or default not equals. Let's do this. Item base. Oh no. You know what? There's an easier way. For each item base item in inventory dot items. So that's using the enumerator that the enumerable we declared earlier. For each item base item in inventory dot items, then we know that this try peak should succeed. And we can just ignore the return value. Try peak item out. I read only list slots debug.log item.name has slots.count slots in the inventory. Okay. And then if Q, we will get item base item equals inventory dot items dot first or default. And if item null debug.log no items in the inventory. Else we will inventory dot try remove no, first we need to get the slots. Oh, what is this one? Right, you see, because it's an inner class, I have to do inventory dot slot. That's my problem. That's why that wasn't working. Slots equals inventory dot try peak item there. Out IEnumerable. I read only list. And try remove item slots dot index. Let's try to do from slots dot count -1. There we go. So we'll try to remove from the last index. So we're just going to be effectively throwing down the last index. Like, yeah. Yeah, Lord. That's probably good. Bool success equals, yeah, debug.log dropped a one item.name. Success. Okay. Let's see if this works. Oh, I realize I'm a bit over time. So let's see. So if we press E, nothing happens. If we press R, we get the thing that there's no, rather Q, that there's no items in the inventory. Pick up a thing. Oh, look, now I'm pressing E. You're just gonna have to take my word for it. And we've got the different test consumables. Let's see. There's a drop one, drop another. We should. Okay, we had 3 in the inventory. There we go. Your inventory works. It just doesn't have a UI. I realize I've missed out the UI bit, but that should be fine. You guys should be able to extend it at the end. Yeah, exactly. Who needs a UI? Only 2 minutes overtime. Awesome. Yeah, I think we're definitely going to give you some more resources on this. That was the last tutorial workshop of the semester. See you next year, I guess. Anything else?
Yeah, can you hear me?
Yes.
Yes, perfect. Okay, because my headphones died meanwhile. So just wanted to mention that workshop 4 will be recorded offline again. And I just got in contact with the person that was supposed to present it, and they said next week. So we're really trying to get a link to it next week and put it on Discord. Sorry for the delay. And yeah, regarding workshop 5, we'll try to put together some resources. So like it will be easier for you to continue if you want to create a UI and stuff like that. And yeah, as Mikolai was saying, this is the last tutorial for the semester. And thank you so much for following with us. And yeah, hopefully see you next year.
Yeah, hopefully. Um,
Yeah.
you may leave. You are free to go.
Thank you so much for
Any final
joining.
questions? Any final questions? No. Awesome. I was just wondering if you had any questions on like content that we had just covered. Oh, I'm very well, thank you very much. How are you? Okay. Very tired. Oh, get some sleep.
Yeah, we feel you.
Okay. Yeah. Thanks again. See you next year.
Bye everyone.